Well, good morning, everyone. Thank you for joining us for our first Wireside chat of 2025. My name is Dan Lorenz. I'm the Director of Vendor Relations with CTIconnect. And today we're very happy to host our friends at Bequant as well as AeroNet Wireless. So joining us today is Luis Cintron of AeroNet Wireless to talk about their experience with the Bequant QOE product. We also have the Chief Technology Officer from Bequant, Jose Lopez, and Steve Kiley, who is the Vice President of North American Sales. So we'll dig right in with a little bit of background on AeroNet's network. Luis, if you can just set the stage, let people know how you have rolled out Bequant in your network. But let's start with the size of your network, the number of subscribers, number that are wireless versus fiber, that sort of thing.
Okay. We are an internet service provider offering internet connectivity and voice services. We also provide a private network through our MPLS network. Most of our customers are small to mid business. We have residential customers too. Our network is a combination of mostly fixed wireless and fiber technology. I would say 90% fixed wireless and the rest fiber. On the fiber side, we have active Ethernet and XGPON technology. And on the fixed wireless is point-to-multipoint wireless radios.
And whose wireless access products are you using today?
Mostly is Cambium network, and now we're starting to use Tarana networks too. And on the fiber side, on the XGPON technology, we have from Nokia, Sienna, and Ubiquiti.
Nokia, Sienna, Ubiquiti. Okay. And you said about 90% of those subscribers are wireless, about 10% fiber, right?
Yeah, that's correct.
Great, great. So I recall you've been using the Bequant product for approximately 5 years. Is that right?
Yeah, that's correct.
Yeah. Help us understand, or maybe we should switch to Jose and have him tell us a little bit about the Bequant product and how it's being used by all users, not just AeroNet, but just give our listeners a background on Bequant's QOE products.
Okay, yeah, thanks, Dan. And yeah, well, I'm going to basically they are using at AeroNet one of our main features, TCP optimization. So while we can do many other things, maybe today we can focus on that feature. Because why would you basically our node Bequant QOE? Which offers this TCP optimization. Why do you need TCP optimization? And the answer is that in a network, the speed of internet downloads is often not limited by the ISP network or the ISP rate plans. Instead, the bottleneck is frequently in the source servers, sending data at a speed lower than what the network can handle. And this limitation comes from the transport protocols used by the servers, whether TCP or quick on UDP, when they incorrectly determine that basically increasing the transmission speed would cause congestion. And this issue is particularly common when there are wireless links, when during the download there is jitter or packet losses, which happens with wireless very often. But links, in fact, you get a lot of this in fiber networks because at the end of every fiber network, there's usually a Wi-Fi link, wireless link. And so in the thing is that if for TCP downloads, we can do something about these transport protocols being the limit. And TCP downloads, which account by, it's around 60 to 85% of all internet traffic. This can be addressed with TCP optimization, with a TCP proxy, such as the Bequant QOE solution. TCP proxies are nothing new. They've been in the industry for over 30 years. Many satellite links use them. Basically, without it, they don't work very well. And it's also being used by many large wireless cellular networks. But the thing is that traditionally this has been a very expensive technology, and at Bequant we have now made this accessible and affordable for regular ISP networks. So how does, if you can please go to the next slide, we can go into how does TCP proxy work. It is a software running on off-the-shelf standard servers. And it is installed within an ISP network. Oh, sorry, Taylor, if you can move to the next slide. Yeah, thanks. So basically, yeah, thank you. It is a software running on off-the-shelf standard servers installed in the ISP network, typically in the network operations center centrally. Our product will do much more than TCP optimization. It will implement rate plans with active queue management. It will do DPI, shaping per application, and provide a very complete network visibility. But today we'll focus on TCP optimization, which is a differentiating feature with respect to our competitors, and which is the one that has been used mainly at AeroNet for the last 5 years. So our TCP proxy functionality ensures that the source servers here on the internet side, usually, they not only, when they send the data, they don't not only send it faster, but they send it exactly at the speed that it's required that the client on the left side, on the access side, can handle exactly at the maximum speed that they can handle. And this is achieved by being closer on one part, just like cache servers. Being closer, you can always make these calculations about the optimum speed much better. But also, you can get this with a better calculation with our TCP, our own TCP that we have developed, which is like the standard TCP, but with better congestion detection algorithms, which we patented around 10 years ago and have refined ever since. And these algorithms prevent congestion and are not misled by the jitter or the packet losses that are very common in wireless networks. So the end result is that we manage to get the traffic that comes from internet servers to come at the higher speed, but higher than they would without us, but without causing congestion. Okay. And if you go to the next slide, please, the results in the end can be seen when you from the real-time measurements that we make. We always leave a very small percentage of all TCP connections going through us without optimization, and so that by measuring them and comparing the results with the results from the rest of the connections, which are all optimized, we can then see how much we are improving the speed. For instance, we have now results, when we go to the next slide, where we'll see in AeroNet what basically the speed improvements that we are getting. So, sorry, Taylor, we can see the next slide.
Taylor, can you advance the slide, please? There we go.
Yeah, exactly. Perfect. Thank you. So here, what we see is that in red, you see the results we are getting for optimized connections, the average speed. And we see that it is, for instance, the average speed for the whole network during the time that this was measured for 1 day. Basically, it went from 5.5 megabits per second without optimization to 6.4 megabits per second with TCPO, 20% faster. By the way, this 6.4 megabits per second average may sound small for a fast network like AeroNet, but it's not because it's the average of millions of connections, most of which are really slow, really small, and cannot reach very high speeds. So if we look at particular services, for instance, Netflix, we see that the improvement is it goes from 14.8 to 19.1, almost a 30% improvement. So, and it's not a small difference because 14 Netflix, for instance, can give you 4K resolution when you're around 20 megabits per second, whereas with 15 you cannot get that 4K resolution. So it's an important improvement. And you can see similar improvements in other services like Apple, for instance, also another 30%. So,
and Jose, is that typical across all operators? I mean, are these really representative numbers of all networks?
I would say yes. In fact, I would say this would be more on the low. We see almost always like this minimum speed improvements, but normally even a bit better, and depends very much on each network. Okay, that's very much. For instance, AeroNet is in Puerto Rico. That means that some services, they have many services very local. With cache servers, but others come from further away. It's just geography. And for those, we can then help more. So it depends very much on the network. But yeah, this would be quite typical, if even a bit low.
And Dan, one thing I would say is that it's really kind of fun talking to the end customers, the actual users of in the home, is that they'll see an actual difference. That they'll talk about when they change applications going from Netflix to YouTube. It's more like changing the channel on a TV remote than it was just watching the Netflix end load and the spooling, and then it loads up. So it's actually it's noticeable by the end user.
Yeah, the thing is that we do it mainly two reasons, right? Because we make the data appear as closer, okay, because we are proxy, and because we have a better TCP. But in fact, if we focus on Netflix, in fact, in the case of AeroNet, they have local caches. If you could please go to the next slide, please, Taylor. There we will see that. Thank you. Most of we see the QE application will give you this the distribution of latencies for each service. In the case of Netflix at AeroNet, it's mostly coming from very close by, from less than 5 milliseconds, which is almost all coming from local cache. So in this case, we are not much closer. They are not; those servers are just basically as close as we are. They're probably sitting on a rack next to us. So in this case, all the improvement, this 30% improvement, is coming from our TCP being better than standard TCP, because those servers could have sent those Netflix server, the TCP in the Netflix servers could have sent the data at 19.1 megabits per second average, just as we did, because the network could handle it. I mean, it has handled it, but when not being proxied by us, they decided, TCP decided to send at an average of 14.8, and that's 30% slower, and that basically was because they were being misled by the jitter and the losses that are typical in wireless and Wi-Fi networks. And so, basically, we can also say that TCP works in both directions. And we can go to, if we go to the next slide, we'll see the uplink results, which are, I believe, usually a bit better even than the downlink. If you, sorry, Taylor, if we can go to the next slide. Yeah, thank you. There we'll see that instead of 20, in this case, it's 30% improvement overall. And for some services like Google or Microsoft, there's a 40% improvement in speed, and even more in, I see there in this speed test, UCLA speed test. So this means that in uplink we are helping basically the results in speed test.
And Jose, one thing I'd
Yes.
ask you, you guys have 500 networks worldwide using this. Is this what you typically see? Because this is what I typically see, is that the upload is the TCPO has a better impact on the upload than the download.
Yeah, that's because, the TCP, we are improving over the TCP that is sending. And, on the uplink side, the server, what is acting as a server, what is sending is usually, like a mobile phone or something. Whereas, let's say, well, from a CPU perspective, then a real server. So we can help there more because they are worse servers, let's say.
Which is really kind of neat for wireless because, typically you'll use a 75, 25, something like that. So you can have better download speeds,
yeah.
but the precious upload speeds are there. And we're seeing, with video conferencing and cloud sharing, cloud data, there's a big increase in uplink traffic. So
Yep. And
Luis, can you give us a feel for just about how much data we're actually pumping through the QoE server?
I think we can see that if they show the next slide, the last slide that I had to show, we'll let, yeah, basically that will be.
There we go.
So basically, I think it's around, close to 40 gigabits per second. And basically TCP, we see it from 60 to 85% of the traffic is TCP. And in the case, in the US, it's usually more TCP. And in this case of AeroNet, we measure is 77%. And it hasn't changed much in these last 5 years. I mean, quite a few years ago when Quick came, there was it used to be all TCP, and then Quick came and it took basically it's all the Meta and Google contents, but that's usually it. So it's 77% TCP. Yeah.
that's on almost all networks, 500 plus networks worldwide. You see, 65, 80% of that being TCP traffic, right?
Yeah, that's it. Yes.
So what's also interesting is that, this is 40 gigs and you guys, we just got, 400 gigs on the server. That's the maximum that you can do.
Yeah. We recently qualified 400 gig servers, but in this case it's they only require up to 40. I think, Luis, you have some extra traffic because of I believe you have also some private networks and stuff like that. But
That's correct. Yeah.
some of the internet traffic mostly goes through this, right?
Yeah, this most the internet traffic. Yeah.
I see.
And for your wireless network, you really have one main internet pipe, correct? But for other ISPs, they may have multiple internet connections to their network, right?
We have multiples. We have 4 now. Yeah.
Oh, you have 4 now. Okay. Good. And then I know with some operators, they'll so you're talking about the maximum server size a moment ago, Jose, but I think some operators use multiple servers at different egress points to the internet, right?
Yeah, exactly. Because sometimes, it's a physical thing. They have different data centers, different locations, and so we are placed before each of the connections to internet.
Just a comment to the attendees, feel free to put in any questions you have in the Q&A window, and we'll address your questions as they come up. So, Luis, walk us through the evaluation process when you first started looking at the Bequant product, and what kind of testing did you do? What made you decide to implement this solution?
Most of the test was speed test to different servers. The implementation was quite simple. Actually, it was a simple process. Our topology is very similar to the diagram that Jose just showed. So it's sitting between 2 routers. And we just reroute the traffic through the box, and that was it. So it was very simple. And after that, we start doing different tests locally and outside. And when you do tests outside, like servers in Miami or Atlanta, you notice the different more latency. You see a more improvement on the test. So, but basically, that was the test that we did.
Yeah, we usually kind of TCP optimization can usually help more when the servers are coming from further away.
Yeah.
Because there's more margin for improvement. You know, I mean, if you have a network that's just with speed test next to you, fiber, and then Ethernet, then there's not so much that we can do. But since that's not the typical thing, you always have at least Wi-Fi, and there's margin for improvement.
Right, right. And the server is independent of the transport method, right? I mean, it'll work with anybody's fixed wireless, fiber, whatever.
Yeah, I mean, all the traffic. For us, it's all IP traffic. And if you're using, for instance, for TCPO and some other functionalities that we have, like automatic congestion management, basically you don't have to do anything. You just turn it on, and it's doing what it does. When it sees TCP traffic, it just does all these local acknowledge certain things that mean, you know, being a TCP proxy, but you don't have to configure anything. Then the UDP traffic is just going through and nothing's being done to it. Now, if you do more things like rate plans or shaping, then I mean, and we always, since all the traffic is going through us, we are analyzing the traffic, so we can always see, you know, how much Netflix, how much applications you may have.
Yeah, if you would touch on shaping a little bit more. I know AeroNet doesn't really use shaping; they're using primarily the optimization of TCP traffic. But just give us a little thumbnail sketch of how shaping works and what it benefits you. How it
Yeah, I
benefits
think
you.
in the case of AeroNet, it's also because because of their topology and where we are placed, they are doing some NAT network address translation before us, so we don't actually see the IP addresses of the real server, the real user, so we cannot do the shaping for them well. So, but if we did shaping, yes, we can implement rate plans with basically with active queue management, an improved version of FQQL, and now we're in fact coming up with more modern methods. And we can also do that would be for all the traffic of all the subscribers. And since we have DPI, Deep Packet Inspection, we can see what traffic is video, what traffic is our teleconference applications like this Zoom. Since we can differentiate different those traffics, we can then apply differentiated shaping to those or differentiated priorities, so that you can, for instance, make teleconference traffic have more priority over video or over software downloads, especially maybe during peak time. Or you can also have, for instance, since we can differentiate speed test traffic, we can have that traffic to have a guarantee, so that, for instance, suppose someone has a 50 meg plan, someone is doing 10 megs on their plan with Netflix, and so if they did speed test at that time, they would get 40, and so, but you can guarantee, for instance, that they always get 50, so that you prove that, you know, your ISP is delivering. In fact, it's delivering more than their plan, but by making sure that they get the 50 megabits of their plan, you're probably avoiding a support call that may sometimes happen, you know, when people do speed test and don't get the speed they sign up for.
Yeah, we see that a lot where, you know, the support calls will drop in half, you know, when you put the QoE in place.
Yeah.
And, you know, those support calls have a cost associated to them. And when you start cutting your support calls in half, then you're saving money, and that pays for the actual subscription to QoE.
Yeah, in the end, this is about the TCP optimization is about getting more speed, which means more quality and fewer support calls. Well, in the end, also those will lead eventually to less customer churn and hopefully more easier customer acquisition. And so the business case for this comes from the extra, basically from the reduction in support calls that will give you, well, that's cost reduction. You'll also get more customers. That if you can measure that, then you'll also get that from a higher quality. And also from the shaping point of view, if you can reduce sometimes the peak, basically, especially for wireless networks, the peak traffic that you are by, for instance, Netflix, they can get 25 megabits per second. That would be the highest. They can sometimes use 100 or 200 megabits per second. If you avoid those peaks, many times you'll reduce the peak bandwidth of your network, and so you'll get basically the same network be able to handle more subscribers. So that's the other part of the business case where we help our customers. Sorry.
And this helps with the gamers too, who are mostly worried about latency.
Yeah, exactly. Because improving the speed is something. Networks are usually not congested most of the day, except when they are congested during the peak time, right? Or more congested. So when you're not in the peak time, then you benefit a lot from the acceleration, for instance, that you get from TCP optimization. Now, when you get to congestion situations, everybody's already under the limit of their rate plans, or many are. So in that, then the game changes. Then the important thing is to be able to give those the limit, whatever they have signed up for, but do it without latency. Because the problem is that when you get to the limit, when you do any kind of speed limitation like you have to do with a rate plan, you end up getting some latency. You can end up getting latency, and latency is really bad for gamers and also for teleconference applications or voice over IP. So if you are able to then the latency and or deliver the maximum speed without incurring any latency, which we can also do thanks to our rate plans, our queuing technology, then there's another area where you start getting better reputation and especially fewer support calls from gamers.
Interesting. Again, folks, if you have any questions, please drop them in the Q&A window. Luis, anything else you'd like to say about your experience with Bequant? Sounds like it was pretty much set it and forget it for you guys. That it just works magic without a whole lot of intervention, a whole lot of management.
Yeah, it's very transparent to us. Yeah, the operation is very simple. And the experience has been very positive. We are very happy with the product. And we, from the beginning, the testing and the implementation and throughout these 5 years of operation has been a very good product.
That's fantastic. Not seeing any questions in the chat. I think we can probably wrap up the call. Anything last minute, we'll stay on for a few more seconds if anybody has a question they'd like to throw in. Beyond that, thank you very much for attending our call today. We'll be having more of these Wireside chats throughout this year. And of course, if you're interested in the product, the Bequant product, contact your CTI sales rep, reach out to me or whoever, reach out to Steve, and we'll get you set up with a trial.
Thanks for having us.
Okay,
Thanks for joining us, Steve. Luis, thank you so much for coming on. And we just got a question.
Okay.
You sure your server in a data center? Do you have a solution for outdoor cabinets?
We have used in some cases some ruggedized servers that can be used outside. So I mean, we use standard servers. So if you can get a server that can work outside, then it will also work with our solution.
Yeah, I've seen the temperature hardened solutions. A lot of them are
exactly.
used in public
There are some
safety and things like that.
Yeah.
Yeah.
Yeah, there's temperature hardened solutions out there, and you can go to Bequant's website, and the hardware requirements are listed on the website.
Yeah, to see the CPUs that we require. So some of those are sometimes less powerful, but well, but then also if you're putting it outside, it's probably because you're putting it like near a tower or something like that. And normally that means that you don't need so much traffic. You're not pushing 100 gigs through those boxes. So there's probably very little requirement.
Very well. Well, thanks again, Steve. Luis, thank you for joining us and providing your insights and your experience. And Jose, thanks so much for the overview. I know it's late in the day for you, so appreciate you joining us at this time as well.
Okay, thank you very much.
That's
Thank
it.
you.
And thank you to our attendees for coming.
Okay, yep, thank you.
Bye-bye.
Bye.
Right.